Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 20 in the cross-site scripting module titled Reflected XSS in Canonical Link Tag. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on cross-site scripting labs, and go down to lab number 20, titled Reflected XSS in Canonical Link Tag. Alright, let's get started. This lab reflects user input in a canonical link tag and escapes angle brackets. To solve the lab, perform a cross-site scripting attack on the home page that injects an attribute that calls the alert function. To assist with your exploit, you can assume that the simulated user will press the following key combinations. So you've got Alt-Shift-X, Control-Alt-X, and then Alt-X. And then we've got a note here saying, please note that the intended solution to this lab is only possible in Chrome. Alright, so we need to perform a cross-site scripting attack that when a user performs one of these key combinations, it calls the alert function. Let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. However, all the features that I use are present in the Community Edition, and so you could just complete the lab with the Community Edition. Okay, so the first thing we're going to assume over here is that you've tested the application and you can't find any parameters that are reflected back to you in the application and are vulnerable to XSS. In that case, the next step is to see if the URL accepts a random parameter. And the way to do that is just to put in a question mark, so a slash and then question mark, and then just say random is equal to test and see if the application accepts that. So let's hit send. The application is still loading fine. Now let's view the page source to see if there's any reflection for this parameter that we just added. So let's do control find and then look for test. And it looks like there is one reflection over here. So hit send and here we go. So the reflection is in a canonical link, which is interesting. Now, since we do have a reflection, we're going to try to see if it's vulnerable to a cross-site scripting vulnerability. So let's copy that and put it in here. Let's remove this space and remove the title line. Now the idea over here is to perform a cross-site scripting attack. So the first thing that I'm going to do is see if I could add an attribute called onClick that alerts on a random string. So to do that, we're going to add a single quote so that we could close off this string right over here, and then a space and say onClick is equal to single quote, and then alert 1. And then this single quote over here will be closed off with a single quote that is present in the application itself. So let's copy that and see how it gets displayed in the code. So if we go back right over here and remove the previous string that we inputted and put the new one and let it load. Interesting. So we can add the onClick attribute. However, notice over here that we get a %20, which is just the URL encoded version of a space sign. This is not a good sign because I do need a space over here. So I'm going to try to find another way of entering a space. And one way to do that is just to add the URL encoded version of a tab sign. So let's say tab URL encode and visit the W3 schools link and do a search on tab. Here we go. So for a horizontal tab, it's %90. So let's try that. If it doesn't work, we'll try vertical tab. So instead of the space over here, you would put %90, and let's see how the application responds. So let's copy our exploit string again, close this off, and add it in the application. Let's remove it from over here and add the new one. And we have 2 backslashes. So let's remove that backslash and hit enter. And let's view how it's displayed in the code. Okay, perfect. So you could see over here now I do have a space, so the tab works, and my on-click element is being viewed as good. Perfect. So right now, I am running into one issue, which is that this link over here is not actually displayed on the page. And so I need a way to trigger this element over here so that I could execute the alert function. And that's why over here they said to assist with your exploit, you can assume that the simulated user will press the following key combinations. And so when the user presses Alt Shift X or Control Alt X or Alt X, what'll happen is I needed to trigger this alert function right over here. And to do that, I'm going to add something called an access key, which is simply just an attribute that provides a keyboard shortcut for an element. So to do that, we'll just close this off one more time and then say access key is equal to. And over here, this could be anything, but because the user, so the victim user over here will be clicking on X, you do have to put X in here. Had this said W or Z or whatnot, you would have to put in the character that is added in the lab description. So in this case, it's X, and so we'll keep it that way. And that's pretty much it. Now notice over here, there is a space sign, and that's not going to work. So let's add the tab URL encoded version. All right, let's copy our new exploit. Hopefully this will work. And let's go to view source over here. Remove the previous exploit. And add it in here. And if we go to the right, you could see over here my access key attribute was added correctly, and I still have my on-click attribute. So now if we go to the lab, so let's remove view source right over here and hit enter. It should say, congratulations, you solved the lab. And the reason it did that is because the simulated victim user performed one of these key combinations and was alerted with the alert message. All right, so we successfully completed the exercise by exploiting the reflected XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.